This should be the last video in a little series about lines and planes in 3 dimensions. Here we're going to talk about given 3 points. I want you to find the equation of a plane. So 3 points in 3 dimensions. You should be familiar from the idea from like life or reality or geometry, whatever you want to call it, that if I take 3 points in space, just put a finger one spot, another spot, and then move around, those 3 points, they define a plane. So if I give you these 3 points here, you're going to use a little bit of cross product and then the equation of a plane in order to find the equation of this thing, or like the formula for the equation of plane. So what I'm going to do to start is actually draw this because I think it will be helpful. Get it to draw it well. Remember, X, Y is over here, and then Z is up here. So remember, I'm in 2D space here on the computer, so I'm going to do my best to try and make it so that you can tell what the 3D components of this are. So I'm going to put my little ticks here, and then put ticks here, and here. And I'm going to go over to a pencil here. All right, so let's do P first. So actually, you know what I'll do? I'll go out 1, 2, and then I'm going to go, so I'm doing, I'm doing 1 to -1. So I'm going to go from the origin out to 1, and then I'm going to go over 2 units. So that would be 1, 2 to there. And then I'm going to go down 1 unit, which will put me here. So I'll draw that in with a little pencil. I went out here, over there, and down there. So it was 1 unit here, 2 units that direction, and then 1 unit there. So now I'm going to put a dot there, and that is P. Now I'm going to do the same thing for the other two. So Q is 0, 3, 0. That's actually not that bad because I just go out 3 units on the y-axis there, and I'll do a little right, so you can see that. So that is, oops, I'm going to change over to this color, Q. And then R is 2, 1, 4. So I'm going to go out 2 units, 1, 2. I'm going to go over 1 unit to the right, 1. And then I'm going to go up 4 units. So the easiest way to go up 4 units is really to be like, all right, well, you could count it out. I'm just going to go to that same spot in the next block up. And that'll be 1 unit, then 2 units, then 3 units, then 4 units. So I'll actually put a little, put a little dot. I got 1, 2, 3, 4. So, and then I'll trace it in. I got this. Oh, man. Doop. Got this, and then that. And hopefully those little gray things sort of help you see where these would be in a 3-dimensional space. So that is my point R. So now what I can do is sketch in a triangle like that. And that triangle would be part of that plane, right? So you can see that it's kind of like at an angle. It's going down. If I were to start at R and it was a sledding hill, we would sled down the hill this way. Okay, so now what I'm going to do is look at 2 vectors. We will go to green. All right, so this vector right here is that I'm going to let it be U. And U is from Q to R, which is going to be something, something, boom, like that. So I got to figure out what goes in there. Well, what I can do is use the coordinates up here from Q to R, right? So 0 to 2, how far do I move? 2. 3 to 1, how far do we move? -2. 0 to 4, how far do we move? 2. So that's this vector from Q to R. The next thing I'm going to look at is I'm going to let this vector here be V, Well, that's not a very good V. V is going to be Q out to P. And you could choose any combination of vectors from one point to another as long as they're two distinct vectors. And this would work and give us the same equation. So Q to P is, all right, so 0 to 1 is 1. 3 to 2, that's also, wait, 3 to 2 is negative 1. And then 0 to negative 1 is negative 1. Okay, so now what I'm going to do is my normal vector, n, I'm going to switch back to this, n is u crossed, am I going to do u? Yep, crossed with v. Why is that? Remember, what does a cross product do? A cross product gives me a vector that is perpendicular to two things. Well, u is a vector that's in this plane. V is also a vector that's in this plane. So if I cross these guys, I'm going to get a vector that is perpendicular to both of these. So I'm going to pause this and draw a little a picture of this so you can see what I'm saying. Okay, so this parallelogram is a plane sticking out in 3D space. It would be this plane up here. Maybe I can zoom out just a little bit. And then u is this vector, so it's sticking out like that within the plane. That's this one. And then v is this one. Bam, it's in the plane. U cross v is orthogonal. This is what the cross product is orthogonal, perpendicular to both u and v. So what I can do is zoom in a little bit and put this for being perpendicular to u, and then come over here, and maybe I'll go like that. It's hard to see. I think that makes sense. And that is perpendicular to v. So it is perpendicular to both of those pieces. So what that tells me is that is my n, my a, comma b, comma c, in my cross product, or in my plane. So I need to do the cross product of u and v. So here's u, here's v. I'll zoom out a little bit. So I need to do n is u crossed with v, which is, do some determinants, I hat, j hat, k hat, and then I'm going to take u, 2, negative 2, 4. 2, negative 2, 4. Now, there are lots of things that we can actually do to simplify this stuff, and I think with experience you will see that. And all right, so next one is 1, negative 1, negative 1. The other thing I'll say is that it doesn't matter if we do u cross v or v cross u. It's going to change the orientation of n, but it's still going to give us a perpendicular vector, so we can still use it. All right, so let me go down here and give myself some space to do this work. So this is, all right, boom, deet, comma, deet, comma, deet. Don't forget the negative. Close. All right. In the first one, I cover up. This is the I hat one, so I cover up this column in that row. So I take 2, 4, negative 1, negative 1. Sorry, negative 2, 4, negative 1, negative 1. And then in this one, I cover up this column in that row, so I get 2, 4, 1, negative 1. And then in this one, bam, I cover up that column in that row, so I get 2, negative 2, 1, negative 1. When I do these deets, I wind up getting 6, 6, 0. These guys are 6, and that's with this negative in there. This deet here is a negative 6, but then this makes it positive. So that tells me that n is equal to 6, 6, 0. Now, I need to do the formula. The equation of the plane is a times x minus x naught plus b times y minus y naught plus c times z minus z naught. This is equal to my a, b, c vector because it's perpendicular. So that tells me that I've got 6 times x minus something plus 6 times y minus, something, undo, plus c is 0 times z minus something. And then that is equal to 0. Sorry, I didn't write that there. So now what I need to do is choose a point. Which point am I going to take? I am going to take this first one, P. So I will copy this and paste it down here. You could take any of those 3 points. I'm taking this one because it you see more you see more stuff with it. So all right, so this is my x naught, this is my y naught, and this is my z naught. So I get x minus 1, y minus 2, and z double negative plus 1. That would be one form of the equation. Typically, I want you to write it in an ax plus by plus cz equals d. So I want you to combine like terms and put the one piece over on the right side. So if I simplify this, I get 6x minus 6 plus 6y minus 12 plus 0z. So the c value is 0 in this case, equals 0. And then if I simplify that, I get 6x plus 6y plus 0z equals, move those over, I get 18. And then what you can do is simplify this if you would like. You could see that everything's divisible by 6, which would take us to x plus y, the z term is 0, equals 3. And I know that it's weird that this thing doesn't have a z term, but that just turned out, that was just the product of having these particular points here. And I wanted points that I could draw easily on this, and you could see them. So that's why I chose those points there. You're not always going to have a z value equal to 0. One thing this does mean is that this thing doesn't change based on the z if I move x's and y's. So if I move back and forth on the y's or on the x's here, it's not going to change the height. So it's actually flat in that direction. We'll talk about more of that stuff later. Anyway, hopefully you see how to find a equation of a plane given 3 points. What do? I create 2 vectors. You can call them whatever you want. I cross product them like this. That gives me my normal vector. And then I take that thing and I plug it into the formula, or you can think about it as I dot this with the x minus x naught, y minus y naught, z minus z naught. And I get this thing. Okay, cool. Hopefully you're starting to understand this equation of planes and also the equation of the lines in 3 dimensions. Thank you. You're awesome. Appreciate you.